Okay, in this video, if you didn't see the past two videos, what we did is we did a basic Altium schematic design and then a layout for that schematic design. In this video, what we're going to do is we're going to take that finished layout design and export it for fabrication. So we're going to find we're going to sort of show how to go through the steps of exporting all the parts of the design that you need to have it fabricated by a fabrication facility, and then we're going to actually do it. We'll just go to sort of a standard, a common fabrication facility and upload it and just sort of see. So we'll just take you through the whole process. The idea of this video series is to really go through from the beginning to the end the whole process of designing a board and printing and having that board printed. So if we go back to our Altium design, we have our Altium design here. There's one thing from when we left last time that I realized we probably should have done, and that is add labels here. So these components, so we have these pins. This is 5 volts, negative 5 volts, ground. The problem is we don't know, after this board is printed, we really have no way of indicating which signal is which. We could guess, but we don't really know. So what we're going to do is we're going to label these now, and we don't have a lot of space on the top because we did these component labels here. So maybe what we should do is use the back side of the board to add the labels for the pins. That'll also be nice for us because it's a nice empty back area of the board. We didn't put anything on there. We didn't even use the bottom layer copper at all. So which we probably should have to give an example of it, but we'll save that for another video. So there's a couple ways we can put a silk screen on the back of the board. So this yellow is already our silk screen on the top. You can see it listed. If we scroll all the way over, it's this top overlay. We also have a bottom overlay. The bottom overlay is it's just the silk screen for the bottom half of the board. Now, not all fabrication facilities will do silk screen on both sides of the board. Most of the low-cost, low-volume prototyping ones will, though. So you just gotta know. You gotta make sure you know your fab that you're using. So if we select bottom overlay, one thing we can do is we can just right now we'll just place some text for these guys. We have bottom overlay selected, so the text that we do should be on the bottom overlay layer. So let's do place string. And so this pin here is 5 volts. So let's just change this to 5V0. Now one thing, this looks good right here, right? This is on the bottom layer, obviously. It looks fine. The problem though is, remember that the bottom, we're basically looking like an X-ray through the board right now at that bottom layer. And so the problem is if we were to flip this board over right now with this here, actually let's do it. Let's place this. So it looks good, 5V0 labeled there, it's going to be on the back. But what happens if we hit the 3 key and go to 3D view, do a shift right click to rotate? Uh-oh. Right, the text that it did, it is on the bottom layer, but it's backwards. And the reason it's backwards is because, we hit the 2 key to go back. The reason it's backwards is because we had it oriented in the proper direction for the front of the board, not for the back. There's 2 ways we can deal with this. One way is we can select this text and we can just do mirror. Right, so that will mirror the text. We can now move it to wherever we need it to be, and then that should be fine. And we can just tell, okay, it looks like it's backwards. It's probably correct. If we go back, yep, it does look correct now. So 2 key switches back to this layer design. 3 key goes into 3D mode. There's another thing we can do too, and we can go view, we can go flip board. So the flip board view flips the view of the board in our design. So now we're looking essentially at the back side of the board. And this is gonna make it a little, if we're doing a lot of work on the back side of the board, this makes it a little bit easier to just kind of see what we're doing. So we can see we got that 5V0 there. Sometimes it's a little tough also we don't necessarily like that we're seeing this top overlay layer. So one thing we can do is, the top overlay is kind of getting in the way of our ability to see our bottom layer, so we can just hide the top overlay if we want. So I just hit the top overlay, makes it a little bit clearer to see, sort of see everything here. So let's finish up with the rest of our signals. So again, it still has to be specified as mirrored though. And this is going to be ground. We also have a ground over here, so hit tab to change. Negative 5V0. Tab again. You know, I don't like that 5V0. Let's just change these to negative 5, positive 5, negative 5, positive 5. Okay, looks pretty good. If we want to check it, we can go to 3D view. Yeah, that looks pretty nice. Okay, so that's our finished board now. Now, just so we don't forget, let's go back and let's do view flip board. Let's just flip this guy again. Oh, and we still don't have our top layer there. So we can open up the layer manager. This is another way we can sort of hide or enable a layer. So we'll go, top overlay, we'll show that again. And again, like I said, there's lots of ways, like I said in the first video, there's lots of ways to do the same thing in LTM. So you can right click the layer, you can left click the layer, you can open up the layer manager, lots of different ways to show and hide the different layers. Okay, so I think we're ready to export. So to export the board, basically you need to take the LTM files, specify all this information about where things are located, what they are, what layer they're associated with. But a lot of these details, things like the signal name and the types of signals that we have, a fabrication facility doesn't care about that. Basically what a fabrication facility needs is they need an image of each layer they need to fabricate, and they need to have a specification of where they're going to drill holes for our design. And that's all they need. That's all they want. And so we have to basically take our LTM design, which has a ton of information, and distill that down into a more basic image that for each of the layers that the fabrication facility needs to do. Now, one thing to note is there's some layers that we're not seeing very well on here. So there's layers that, as we add things like pins, there's layers that are being defined that we might not see. So for instance, if we do top solder, right? This top solder layer, this was specifying all the areas where we should not have solder mask. So basically the rest of this board is going to be covered with a solder mask layer at the fab. These little purple areas are going to not have that solder mask layer. But I mean, they're there always. It's just a lot of times we don't really see. You can kind of see that faint little purple around there, but sometimes we don't see them. We're going to fabricate these all. We're going to export these all layer by layer. So to do this export, we have to make sure that our board file is selected, and then we go File, Fabrication Outputs. The first thing we're going to do is those files that represent the image, the images of each layer. So we're going to export Gerber files for our fab, and it's pretty standard for fabs to use Gerber files. So there's a couple things we want to do when we set this up. So we're going to do 2:5 format for specifying the resolution of this. So it says right here, but basically these are different coarsenesses of specifying the positions of things on our board design. So 2:3 is 1 mil resolution, 2:4 0.1 mil resolution, 2:5 0.01 mil resolution. So 2:4 or 2:5 should both work. Check with the fab, make sure the fab can handle whatever design you'd want to send them. We're going to do it at units of inches too. So the next thing we want to do is we want to do our layers. So there's only a few layers that a fabrication facility needs. So a fabrication facility basically needs to know what your copper pattern looks like on both the top and the bottom of the board. So top and bottom copper. They need to know what your solder mask layer looks like on the top and bottom. So that's the solder mask is a coating of a polymer that solder doesn't like to stick to, so it basically keeps the solder from bridging and things like that. The solder mask layer for the top and the bottom, that's 4 things. Then we need to have a silkscreen layer for the top and the bottom. So to specify what sort of text or whatever is written, and silkscreen is just a visual indicator for people who are looking at the board of sort of what's going on the board. We need that for the top and the bottom. We're up to 6 different layers. We also need to have a layer that shows the outline of the board. So where to cut the board. After they finish designing your board, they're going to put it in a router, and they're going to cut around the board to cut out the actual outline. So we also need one for that. Well, let's go back to this. 7. There's one more file that we need, and that file is the drill file. So the drill file basically specifies where each drill hole is, where each hole through the board is, and how big that hole is. So that's 8. We have 8 files that are typically critical. Now there's some files that we would like for our own purposes too. For instance, if we intend to do a paste stencil, so if we want to do a solder paste stencil for our board, then we might want to export that now while we're at it. We might as well have it. We don't need to send it to the fab, or maybe we do send it to the fab and have them make us a stencil. But those are options. We'll do that in this case. But I'm going to start by just showing what you need for most fabs. So for most fabs, you need the top overlay. You need the top paste. You need the top solder. You don't need the top paste. Sorry. You need the top layer. The top layer, that's that copper layer. You do need the bottom layer. That's the bottom copper. You do need the bottom solder, that's the solder mask. You do need the bottom overlay, that's the silkscreen. That's our 5-volt ground labels, etc. So you also need the keep out layer. So the keep out layer was what we used to define the outline of the board. A lot of people will use a different layer, right? So maybe the outline of the board will be mechanical 5 or mechanical 10 or mechanical 13 or something. Just know which outline you use for the outline of your board, and also know that your fabrication facility may require you to change the name of that file. A lot of fabrication facilities require a .gko file for keep out layer when they accept your file, so make sure to know. So these are what are required. These are what are required for the fab. We have these 7. The drill file we'll do later through a separate process. We are also going to do the top paste. Right, so if we want to build ourselves a nice little stencil for that part, we'll do the top paste. And you know what? The stencil cutter that we have, it sort of cuts Mylar at an angle. So we kind of like to use the stencil upside down so that our solder doesn't stick. So I'm actually going to mirror that. So it's going to do a flipped image of that stencil. Okay, but again, these were just for our benefit. We're not going to send these off to the fab. These are just for us. So we got all the files we need. The rest of these don't generally matter as long as you're using an aperture that your fab's okay with. We're not doing the drill drawings in this particular export method. We'll do a different method for that. Okay. So, and we don't really want to have, for us, we don't want to have mechanical layers added to all plots. Some fabs like that because it helps sort of keep everything aligned, and it's a way to sort of have a common reference shown actually in the image for these different plots. We don't necessarily want that though. Okay, so we're done with that. We're gonna click OK. The software is gonna produce these Gerber files. The Gerber files are, so each of these layers is a different Gerber file. So the light, the pink, the fuchsia or whatever, the purple, the red, the yellow, the whatever that would be, puce, I don't know. So one thing we don't have is we don't have a bottom copper. So we didn't use bottom copper for this board design, and that's fine. Well, we might have a bottom copper. We might have a bottom copper where these guys are. We'll just have to sort of see. I don't remember. Yeah, I bet we have a bottom copper for these pads. It's just not showing up. Okay, so now let's, we've got those. This Camtastic file, Camtastic is a software sort of bundled with Altium that's used for viewing Gerber. So this Camtastic file is sort of viewing all of these Gerber layers separately. But what we did when we did this is we generated a bunch of, if we go to Documents, Altium. So if we go to the folder for our project and we go to Project Outputs, you'll see we generated all of these Gerber files from going through this process. So we generated separate files. They're shown as sort of one unified file here, but in fact, it produced a bunch of separate files. One more thing that we need, and that is we need a drill file. So we have to go back to our board. We should have saved this too. So we're going to go back to our board, and we're going to go File, Fabrication Outputs, NC Drill Files. So again, we can choose the resolution we want for the positioning of these drills. Just for our fab, we're going to do keep leading and trailing zeros, and that's all that we really have to change. Okay. So now this basically showed, okay, we have these drills in these locations with this size. These are for our through holes for those port connections there. Okay. Okay, so now we've exported all the files we need. We're going to go back to that folder. So this is our project folder, project outputs, and we're going to select all the files we need to send to the fab. So we are going to select bottom layer, bottom overlay, bottom silk, keep out layer, top layer, top overlay, top silk. We don't need that paste. This paste file here, this GTP, that top paste file is just for our benefit for making a stencil. Then we need this text file is our drill file, and there's a couple ways to tell that. One, we generated the drill file last, and so this is the sort of the latest date modified name, but also just the text file is going to be the drill file. And then we can take all these. So these are basically the 8 files that we need. These are the magic 8 files we need for fabricating a PCB. So we're just going to zip these up. And we'll call this okay. So now we've got ourselves a zipped up file containing all 8 of our designs. Let's go to a fab. Let's go to a common fab. Let's go to PCB Way. They're really good for, not PCB Way, sorry. PCB Way is good, but they're shipping from China, so they have kind of steep shipping. If we have a relatively small design, relatively minimal quantities, OshPark is just fantastic. So, so we can get started uploading our design. It says to select a file. We can just drag it over. Oops. And we got an issue here. The keep out layer was empty. Huh. That's weird. So we had a little mistake. Well, that's fine. So again, we'll just pop this on a mechanical layer. We'll make this guy mechanical 5. So, change that outline to mechanical 5. File, fabrication outputs, Gerber files. So instead of doing the keep out, we're going to do mechanical 5. And then all we have to do is go back to our folder. So now we have our keep out. We can just delete that. and change our mechanical 5 to keep out. And then we'll go back to the zipped up file, delete the keep out we had. Okay, so moral of the story, don't use the keep out layer for your keep out. use just some standard mechanical layer. And we'll paste this guy back in the zip folder. Okay, so now we should be good. Let's go back and okay. So you'll notice they accepted the board. It all looks good. They said correcting drill precision. Please verify drills aligned correctly. Probably they didn't like that we did a 2 to 5 drill resolution. They probably wanted like a 2 to 4 drill resolution. But it looked like they corrected it. So we can sort of see. So we'll do email. Okay, so this lets us sort of view everything. It looks like everything is correct. It looks like they did everything correct. But this is sort of one last chance we have to make sure everything's right. It looks good. We click approve and order. Boom. Costs us $1.75, which is crazy cheap. Yeah, maybe we want more. Maybe we want, 20. Oops, 21. And then we just check out. To buy this board, we just click checkout and we're ready to go. There's some options too. We could do 2-ounce copper. Be careful if you do 2-ounce copper. You probably have to have a higher, sort of thicker traces. I think we'd probably be okay still for our design. And you can pay a little extra for faster service. I don't think it's a little extra though. I think it's a lot. Okay, and then we're ready to check out. Right, so that board that we just designed, we can enter our shipping details here, buy it directly. So that's the process. That's the process from sort of start to finish. Made a couple mistakes, fixed a couple mistakes. So I think hopefully now you should be able to at least go through this process on your own. There's of course things we left out. We'll have additional videos that sort of go through more details of things you might encounter with different designs. But for now, this is a great way to get started using Altium. Thank you.